Okay, so hello everyone. Welcome to the Dandelion Physics series. In today's video will be about our Unit 1 measurements and uncertainties. Okay, so in this video we're only going to cover a part of the contents included in the topic 1.1, which are the SI units and the derived units, and the rest of the contents included in the topic 1.1 will be covered in future videos. Okay, so to start off with, so in physics, we're always try to measure some values and those numbers that we are interested in. So maybe a really big number, so maybe the radius of our galaxy, or like some real small values like the radius of a electron. So we're always trying to measure something. So for example here, I got two pictures, a bomb and an ant. So in the first picture, maybe we're trying to measure the force exerted by the bomb on its surroundings. Or maybe what is the rise of the temperature after the bomb having exploded. Or maybe in the second picture, we're trying to measure the length of the ant or the height of the ant. So here, when those scientists from all around the world they gather together and they're trying to do some researches or those investigations together, I bet there must be some standards, right? There must be a standard that they all share so they can do those experiments together. And why am I saying this? Because from different cultures we have all those habits. So for example, it's like so in some countries when you're trying to measure the length, so for example the length of this ant, so in some countries they might use the units like inches, or maybe they are going to use centimeters or decimeters or meters or millimeters. So here we have to have a standard that which one are we going to use and which one are we going to use like throughout like the entire experiment. So there must be a standard that we share so that we can collaborate together more effectively. And yes, there is one. So there is one that we all share. So it's called the International System of Units, abbreviated as the SI. Okay, so here, there are seven fundamental units that we have to know here. So the first one is the mass, measured in kilograms, the length, measured in meters, time, measured in seconds, thermodynamic temperature, measured in Kelvin, electric currents, measured in amperes, luminosity, measured in candela, and the last one, the amount of substances measured in moles. So, in order for like to help us to travel in our journey like more smoothly, I recommend you guys to memorize them, like to memorize all of them. But however, I don't really like the word memorize. I believe it sounds kind of dumb. So in the comments below, I'm going to include a link here or a picture that I'm going to post about the exact definition of these units. So instead of just trying to memorize them, you can actually try to understand them, and which will be much more efficient. Okay, then I do have a question here that like why are we doing this? Like why bothered of doing all this stuff like setting a standard and having like those fundamental units, like the most basic ones? Like why are we even doing this? And I believe you already have an answer here. So the answer is that we have to have a shared science language across the world, so that when those scientists from all around the world they get it together and they do those researches, experiments, they collaborate, so that will avoid, like to avoid those language barriers and to avoid those vocabulary confusions, so then we can facilitate the international collaboration between those scientists. So hooray, we all better off. Okay, And then we're going to talk about the derived units here. So when we're talking about that we're going to derive something, sorry, it means that we're getting something from another thing. And that's exactly what's happening right here. So the derived units are expressed in terms of the SI units, which means that the combination of those SI units that are going to make up our derived units. And I'm going to give you a few examples here. Okay, so the first one, if we have some previous knowledge here, then you know that the velocity equals to the change in displacement over change in time. And since displacement is a measurement of length, length, it means that it's a SI unit. And then time here, we know that it's an SI unit. So the length is measured in meters and the time is measured in seconds. So we can derive that the units for velocity here is meters over second. And it's written in this form. And here is something that we have to pay attention to is that a lot of students, they would like to write meters per second in this way, so meters per second. And I prefer this way too, but however, the IB preferred way is to write it in this form. So we have to have a good habit here, or you will be marked down. Okay, and then another example here is that the acceleration equals to the change in velocity or a change in time. So we have already derived the units for velocity, and that will be meters per second. And the unit for time is seconds. So the unit for acceleration is meters per second over second. So that will give us meters per second squared. And that will be the units for acceleration. Okay, so here, velocity, acceleration, they will have a derived units. Derived. They're being derived from who? From the SI units. So the combination of these SI units, they make up our derived units. And that's the logic here. Yeah, and so to summarize what we have done today, we learned about the seven fundamental SI units that we have to memorize. So here, these things we have to to know them. And then here, the derived units, they're expressed in terms of the SI units. And that's all the contents today. Okay, so if you have any questions, please comment down below. And if you would like to stay tuned for further videos, please click subscribe and see you next time.